In this video, we're going to learn to derive logarithmic and exponential functions. All the formulas used in this video are provided in the video description below. Let's start with deriving logarithmic functions. It's important to note that there are two kinds. There's the general logarithmic function and there is the natural. The general has a form of log with the base of a function. And the natural looks like natural log of a function g of x. Now, how do we derive these? Derivative of a general function equals to the derivative of the function over the function over natural log of the base. The derivative of a natural exponential function would be derivative of the function over the function. Now that we have the formulas, let's do some examples. Let's derive log base 2 of x. The derivative of this would be the derivative of the function x, which is going to be 1 over x itself times ln of the base 2. Let's do another example. Let's do log of base 5 of 6x plus 7. The derivative of this would be the derivative of our g of x, which is 6x plus 7, and that's going to be 6 over 6x plus 7 times ln of 5. For the examples for the general log functions, now let's do derivatives for the natural log functions. Let's do some examples. Let's start with a simple one. We're finding derivative of natural log of x. The derivative of this would be derivative of the function x, which is 1 over x. Let's try to derive natural log of x squared plus 4x. Derivative of this would be 2x plus 4 over x squared plus 4x. This was the derivative of the g of x. And this is the g of x itself, using this formula. Now let's do another one. Let's derive natural log of x squared plus 2 squared. Here, it's important to note that the g of x now is this whole thing, including this power. So when we derive, we make sure to find the derivative of the outside function as well. So using the chain rule, we bring that power down, we derive the outside function, this would be power 1, times derivative of the inside, which is 2x. This whole thing is the derivative of g of x. Now the denominator is going to be x squared plus 2 squared. Now we will derive exponential functions. Exponential function has also two kinds, the general kind and the natural exponential function. General has a form of a constant raised to a power, which is a function. The derivative of this would be b raised to that function times derivative of the function times natural log of b. Natural exponential function has a form e raised to a power g of x. The derivative of this would be e to the g of x times derivative of g of x. Now let's do some examples. Let's derive 5 raised to the power x. This would equal 5 raised to the power x times the derivative of the function x, which is 1, times natural log of 5. Let's do another example. Let's do 5 raised to 3x squared. This would equal to 5 raised to 3x squared times derivative of 3x squared, which is going to be, using the chain rule, it's going to be 6x times natural log of 5. For the natural exponential functions, we're going to derive e to the 4x as an example. This would equal to e to the g of x, which is 4x, times the derivative of g of x, which is 4. Another example would be e to the x squared. Derivative of this would be e to the g of x, e to the x squared, times derivative of g of x, which is 2x. Now we need to apply everything we learned to solve a few more examples. We'll start by deriving the given example. We're trying to find the derivative of the general exponential function minus the natural exponential function. This would equal to the constant to the x times natural log of the constant, using the rules we learned previously, minus 5 times exponential function to the x times the derivative of g of x, which is 1. So this would be 4 to the x natural log of 4 minus 5 e to the x. In the next example, we're deriving e to the x times natural log of x. Here we also apply the product rule, and we derive the first function. That would be e to the x times the second function, which is natural log of x, plus derivative of the second function, which is going to be derivative of g of x, which is 1, and by over g of x times the first function, e to the x. Next problem would be to derive 5 to the x times log of 2x. Now when we don't have a base for the log, we know that the base would be, in that case, 10. Here we apply the product rule since there are two functions that are being multiplied, and we're gonna find the derivative of the first function, which is 5 to the x times natural log of 5 times the second function, which is log of 2x, plus derivative of the second function, which is going to be the derivative of the g of x, which is 2 over g of x and over ln of the base, natural log of the base, times the first function, which is 5 to the x. Lastly, we will derive log base 6 of x times log base, in this case it's going to be 10, of x. This would equal to derivative of the first function. It's going to be 1 over x times natural log of 6 times the second function, which is log of x, plus derivative of the second function, which is 1 over x over natural log of 10, since the base is 10, times the first function, log base 6 of x. I hope this video was helpful. See you in my next video.